folks, so my presentation is going to be an illustration by contrast of Jill's point, so I'll probably break every rule that she just gave in presentation. Never follow someone who's talking about how to give a presentation. All right, so I'm Chris Dumas. I'm from the University of North Carolina at Wilmington. I'm in the Department of Environmental Sciences, but actually I'm an economist. So I'm going to talk today about adding logic and proof concepts to your introductory courses in economics or in environmental science. So motivation, I went to this same session last year at the SEA meetings. I loved it. Jill presented a method of using rhetoric. Rhetoric is used in economic arguments. Love that. I've been thinking similar things myself. Subsequent discussion with Jill, we explored methods of rhetoric and logic and proof as complementary methods of persuasion in economics. So I shared some things I've been exploring in the classroom related to teaching logic and proof methods in lower level courses using words, not math. And she suggested I share them, so here I am. Introduction. So theorem. If preferences for good X with price P are independent of other goods Z with prices Q, then demand for X can be written as X of PY, where Y is expenditure on X. All right, so there's a theorem. So here's Varian's proof of that. He says, quote, the proof is straightforward. Assume that X does not solve the problem above. Instead, let X be another value of X that satisfies budget constraint yields strictly greater subutility. Then the bundle would give a higher overall utility, which contradicts the definition of the demand function. Boom. He doesn't even say the proof is finished, right? So many budding economists freak out upon encountering such proof by contradiction methods and become marketing majors instead. You don't want that to happen, right? So another example of indifference curves don't intersect, right? That's what they're trying to prove. Assume X, assume this and that. That is, he starts off by saying suppose not, suppose that's not the case, and then in other words he rephrases that. And then by definition of something from the axiom of transitivity, but this contradicts the assumption that X is strictly preferred, this contradiction establishes the result. All right, so I don't know how many proofs like this you guys read in your graduate work. I ran into a lot of them. Microeconomics is not the only one to blame. Here's proof by contradiction in macroeconomics, another example, or proof by induction, another type of proof that freaks out students a lot of times. Turnpike theorems in macroeconomics we often done by proof by induction. Also a lot of game theory theorems are proof by induction. So the problem as I see it is, unless a student was a math or philosophy logic major or double major, he or she doesn't usually have much exposure to some of the commonly used methods of proof in economics. When students encounter these methods in higher level classes, they're totally unprepared. The higher level problems are complex. Students think the problem is that they do not understand economics, when often instead the problem is that they do not understand the method of proof that's being used. Right? And even if students were math or philosophy majors or double majors, they typically have experience with these methods only within the narrow field of application of their major and don't see the generality of the methods, don't see how the methods can be applied in many different areas in economics, environmental science, and so on. For example, math majors have experience using proof by induction to prove useful things about laws of natural numbers and definitions of irrational numbers and things we use every day, things like that, right? But they don't realize that these same methods can be used in economics to prove useful, well, from my perspective, things, and importantly, how and when the different methods should be used. All right, this is not a problem in all cases. Students do have exposure to a method of direct proof through proving theorems in geometry class in high school. I mean, they know what a basic proof is. Also, many economic models are constructed via direct proof. For example, given a utility function and a budget constraint, drive the demand curves, right? You find the demand curves by sort of direct proof, all right? As a result, students typically do not have unusually large problems with direct proof, right? They kind of understand what's going on. Those types of proof they seem normal, they don't seem weird, all right? So, but other types of proof do. So my point, proof concepts should be introduced early. Ideally in intermediate level classes at undergraduate level, using less complex, intuitive examples so that students understand the methods when applied to more complex problems later on. Actually, I think the methods are of such general applicability across all fields of study, engineering, chemistry, everything. I would argue they should be introduced in principles classes. Right? The basic methods of proof can and should be taught with examples that are discipline specific. So we want econ examples. We don't want to prove that n plus 1 is inductively the natural numbers or whatever. We want something with econ specific, and we should look at these proofs as they do in terms of words, not in terms of math. And when you're first learning the types of proof. So once the idea of a certain type of proof method is understood in word examples, then it becomes much easier to recognize when that method of proof is being used, know when to use it, and know how to apply it when math is involved later on. All right, so here what we're talking about is focusing on deductive reasoning. So this is my general picture of all of economics. You've got some data, use some inductive reasoning, some econometrics to get a model, get some equations. Then based on those equations, you do deductive reasoning, micro and macro theory, and that gives you some results and theorems those are testable results that you can then go back to the data, try to test those, and gradually improve your model. For example, we might have data on prices and quantities. From this data, we get an estimated demand curve and supply curve. We put those together, solve for equilibrium. So what I'm talking about using logic and proof is this deductive reasoning part, going from our models to results and theorems that come from the models. All right? So the methods we're going to use are logic, math, and proof. Students need introduction to the basic terminology. I always ask my class, how many of you had a logic class in college so far? Like 1 person out of 40, right? Or raise your hand, but not many, right? Undergraduates, I think there should be, but no. Students need introduction to basic methods of proof. Students need to see the generality of the terminology and the methods so they can recognize and understand when a method is being used and know which method to apply to novel problems. And that's the ultimate goal. When they encounter a problem later on in their career that's new to them, which method should they use? So what do I do? So in one lecture, 1 hour and 15 minutes, I introduce the basic logic terminology. So what is a statement or proposition? What's the truth value of a statement? Negation of a statement? What's a conditional statement? A significant statement? A leads to B. What's a valid argument? What's an invalid argument? What's a contrapositive argument? Converse, inverse arguments? Counterexample, refutation, biconditional, if and only if arguments? What is a sound argument? And what are necessary and sufficient conditions? So I go through all that. It's definition, 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 definition. And they're like, all right? So, and also, in that same hour and 15 minutes, I go through the 5 basic methods of proof. Good news and bad news. Bad news, we're going to do proofs in here. Good news, there's only 5 methods. All right? So all proofs can be breaking down to these 5. Direct proof, proof by contrapositive, proof by contradiction, proof by induction, proof by counterexample. So we do that. So that's the first day. So they go, they're like, bewildered. All right, going home. But then the next day, we do examples. An example, this is where it really sinks in. Examples with words. And first, so here's an example with basic terminology. All right? If it rains on my corn, then my corn will grow. All right? Sufficient condition, necessary condition. And we go through and talk about why the if part is the sufficient condition and why the then part is the necessary condition. All right? If it's true that it rains on my corn, it's true that my corn will grow. So knowing that rain falls on my corn is a sufficient condition for concluding that corn will grow. But is it necessary for rain to fall on my corn in order for the corn to grow? No, because I could use sprinklers instead, irrigation instead. Therefore, rain falling on my corn is not a necessary condition for corn to grow. All right, and so you can kind of go through some word examples to kind of explain some of the concepts. All right, so here's another sort of exercise I do to look at basic terminology. So look at the red. If the market for product Q is perfectly competitive, then the efficient quantity of Q is produced and consumed. Right? So that's a theorem we're all familiar with. A leads to B. So I go through and I ask the students, okay, for this argument, what's the premise? What's the conclusion? Is the argument valid? And I talk about how the argument is, A is a statement, B is a statement. The argument is the link from A to B. Is that link true? Is it valid? Is the link true? Is knowing that the argument is valid all you need to know to conclude that the argument is sound? If the argument is sound, you know that B is true. All right, what is the converse of the argument? Is the converse valid? What's the inverse of the argument? Is the inverse valid? What's the contrapositive argument? Right? And so by taking something that they're familiar with from the principles course and breaking it down using these terms, they become familiar with what the terms mean in terms of economics. Here's another example that I use a lot. If a firm behaves as a monopoly, then the firm sets the price of its product where marginal revenue equals marginal cost. And so we talk about that. In other words, if the price of apples increases, ceteris paribus, then the quantity of apples purchased decreases. All right, so we go through all of these, go through these different concepts, and then I say in the green, now, what happens if we drop the ceteris paribus part of the premise? What happens to the validity of the converse and the inverse arguments? All right, and that really brings out sort of their understanding of what ceteris paribus really means and why the heck we're saying ceteris paribus. Because now what's valid and what's not all shifts around, right? And they can see that happening, but now they have the terminology to talk about that and describe that in general terms. All right, so what do I do? Homework and exam questions. So here's an example, basic terminology, homework question. Suppose a businesswoman says, if I lower the price of my product, consumers will buy more of my product. This argument may or may not be valid, but let's suppose it is valid. Multiple choice question. What's the converse of the businesswoman's argument? All right, what I've got here is the converse, the inverse, the contrapositive, and something else. All right, and so one of them will be the converse, the others are these other forms of the argument. Given the original statement is valid, is the converse valid? Right? What's the contrapositive of the businesswoman's argument? Right? And it's important to be able to identify converse, inverse, and contrapositive arguments, because if you have an original argument, the contrapositive argument is always, if the original argument is valid, the contrapositive is always valid. But the inverse and the converse may not be valid, may or may not be. All right, so here's some more examples. Given the original statement, is the contrapositive valid? What's the inverse of the argument? Given the original statement is valid, is the inverse valid? Suppose the businesswoman's argument is valid. What additional bit of information would make the argument a sound argument for a certain conclusion? All right, here's another one. Suppose a government official says, if Germany falls into a recession, then the euro currency will collapse. All right, that's an instant statement. So we can go through all those different bullet points, different things we can talk about that. Now, so what about a question about proof by contrapositive? All right, so the contrapositive is the reverse opposite statement. So if A leads to B, the contrapositive is not B leads to not A. All right, and it turns out if A leads to B is valid, then not B leading to not A is also valid, right? So suppose someone interviewed on a cable news show claims if the tax rate on wealthy people was reduced, then the economy grows faster. Right? Suppose it's not currently possible politically to reduce the tax rate on wealthy people. Which of the following alternative arguments is equivalent to the original argument and can provide an alternative way of testing the argument? So one of these is the contrapositive, and the point of this example is to have them start thinking about using the contrapositive as another way of attacking a problem, another way that they can try to understand an argument, determine whether an argument is valid or not. Some more proof by contrapositive ones I do. If the government needs to give a $700 billion bailout loan to banks, then we need to change banking regulations. All right, so go through that. If a firm cheats on the last turn, then the firm will cheat on the first turn. So this is a game theory example. You can go through that, and so that's what you can also do. Proof by contradiction. These are proofs that start out suppose not. All right, so suppose an economist makes an assumption about consumer behavior, and based on that assumption, she derives two results. One, the consumer will purchase a new car, and two, the consumer will not purchase a new car. What does the economist prove? Right? What the economist prove is that her initial assumption is false. Right? Because in proof by contradiction, you make an assumption. If it leads to a contradiction, you know your initial assumption was false. Right? And so that's useful if you wanted to prove that initial assumption was false. Right? You assume that it's true, and then you can go through to contradiction. So a lot of students, this is like that variant example we did at the very beginning on the second slide. All right? So a lot of students are very confused by proofs by contradiction, but they're used a lot, especially by variant, in economics theory papers. And so suppose an economist assumes a firm is not a monopolist. Based on that assumption, she derives two conclusions. The firm will set a very high price for a product. At the same time, the firm will set a very low price for the product. What does she prove? And you're trying to get them to see the pattern. You give several, in terms of repetition, show them several different examples, and get them to see that in all these cases, there's an assumption that leads to a contradiction. And what that means is that the assumption is not true. The assumption is false. And they get it. You do a few of these, and they start to get it. Whereas if you just used a math example of contradiction, it's really hard for them to get it. Proof by induction, the following dominoes types of proof. Right? So suppose there are many fast food restaurants located along a circular highway around a large city. Suppose it is true that if any one of the firms lowers the price of its product, then firms on either side of it will also lower the prices as well. Suppose you also know that firm A lowers its price. What can we conclude that will happen to the prices of all of the fast food restaurants on the circular highway? Right? And they can, for an example like that, they can see the falling dominoes. They can see the proof by induction. And so you can go through several more examples, other examples like that, and they start to get a feel for what proof of induction is and what types of situations would be useful to use proof by induction to prove something. More falling dominoes. This is a game theory, falling dominoes. So conclusion. So basic logic terminology and proof methods should be taught early using words, not math. This can be done. I've done this in my intro-level classes. It works. The students learn it. We teach it using examples like these word examples. They can identify what type of method, what type of proof method is being used on exams, and they can give little examples. And they can answer the questions about them: inverse, converse, contrapositive. So it works. Testing and assessment need not be onerous. They can be multiple choice, like I showed some multiple choice examples. The key is repetition of the same term or method over several application topics at different points in the course. Students can begin to see the generality of the terms and the methods and see how the same method can be used in different ways. The goal is to have students recall a potentially applicable method when encountering a novel problem in the future. Right? You want them not to forget a tool that's in their workbook. Right? To have all these potential proof methods available and be able to pick out which one is useful in a potential situation in the future. So I thank you. Proof. Suppose not. I would immediately leave to prepare my next presentation and not stand here waiting for your wise, insightful questions. Yet, here I stand. A contradiction. Therefore, I thank you, as was to be proved. So if you like thinking about these kinds of things, you're interested in including some of this stuff, I highly recommend. This is a great book, How to Read and Do Proofs. Not just for your own learning, you may know this, but for examples of how to teach it to students, it's a good book. And if you'd like some of these examples, I'd be glad to send them to you. Just send me an email. Thanks.
Yeah. So I think this is very cool. I'm curious about how you balance the opportunity cost issue, because like the examples that you gave us of test questions and exam questions and homework questions are about the thing, about like what kind of proof this was, etc. And you know, mostly in Principles of Micro, we're not interested in that. We're interested in you thinking about micro stuff. So I'm just wondering how you think about opportunity cost versus other things you can do with that time.
Well, I only spend like a day at the beginning. Usually it's like the second day or third day going over those the different terms and the types of proof. And then throughout the semester, I bring in the examples whenever they pop up. And we'll talk about the economics, and then I'll say, oh, by the way, what type of proof is this? And they'll be like, and then you say, remember, it's a proof by induction. And they're like, oh, yeah. And by the end of the class, they know. When you tell them some concept, you say, so what type of proof is going on here? Or what's the converse or the inverse of this? They know. They can figure it out. So just a repetition over one semester is enough. And I think they're very valuable, generalizable concepts and terms. Useful, yeah.
Me?
Yeah.
Oh.
Any question?
Yeah, I wouldn't even think about the opportunity cost of time. This just seems so valuable to me. But I wonder, because what I'm assuming is that they're not only taking it to your class and taking it further with economics, but they're linking this to other classes. Do you get comments from students like that? Do they?
I do. After they'll say, yeah, I was able to use this in my other classes and concepts. Think, why didn't I learn this before? Why didn't I have a logic class? And I say, I don't know. Why didn't you take a logic class? You should have, But even then, the students who have taken a logic class, they in their brains, logic is over here in logic class, and they don't. Those are the ones who have logic. They don't use it in economics. This is trying to kind of bridge that gap. And I thought Jim Casey would be the one to ask that, but I knew somebody was going to ask that. So good. I'm glad you feel different, Jim Casey, on that particular question.
Yeah, I would think it would apply to even humanities.
Oh, yeah.
Oh yeah, everything. So and that's what I'm trying to include in my class in economics, some generalizable concepts and skills that can apply more broadly. And that's what I thought. So, I know for myself, I had some of these proofs in math classes as an undergrad, and then when I got to grad school, it didn't become clear until only later how everything all fit together. I think stuff like this would have really helped me.
Yeah.
So bring it together.
Thank you.
Thanks, folks.